Okay. The million-dollar question is, what is the correct greenhouse for what I want to do? But before you get there, you actually have to realize, where, how, and why do I want to grow a certain product. So in other words, once you have determined what product the market wants, where the market is, you can start with the decision on how you want to grow it. Do you want to grow it in a more cost-saving manner? I put some real old pictures on there, I believe. Or do you want to go super high-tech? And these days, there are some good choices out there. There's some very advanced greenhouses being built by village farms with the Gates project, by Howling nurseries with the Kubo greenhouses, by Windset with the advanced version of the Kubo greenhouses. Yet, that doesn't necessarily mean that that is the right choice for everybody. These, as Michael DeGilio pointed out yesterday, these are very high investments. I think he quoted 42 million for a 30-acre. That's a lot of money. There are a lot of choices to make, and there is a greenhouse that fits almost every budget. And there can also, of course, be growing spaces, like we just heard in the previous presentation, that are indoors. And it can be very cost efficient as well. So, which choices to make? What I've basically tried to summarize here is that the business that we're in, it comes down to a couple of key questions. And I try to address this by the history of greenhouses in this case, and by the crop of tomatoes. And just to show you how much progress we've made over the last couple of years, let's say 30 years, and what it ultimately comes down to. And I'm going to peek over my shoulder. So when you look at when we look at these first greenhouses, the very first ones that went up in the air, in the tomato business, we were doing about 30 to 35 kilos of tomatoes, as well as a round of lettuce. And what was the main reason why that happened? And it was basically we got somewhat control over our climate in which we were growing. Next came hydroponics. Okay, we could all of a sudden do 45 kilos. It didn't happen overnight, of course. It took quite a learning curve. But again, what was the main reason why this happened? Better water and fertilizer control. Then we started adding CO2, and hence photosynthesis. Then you get to the steps where you have grafting, more light in greenhouses, better glass, clearer glass, and all of a sudden we're in the 55 to 60 kilo range. As you notice, we've already gone up almost 50% in a very short time frame. Finally, we get some supplemental lighting in the last couple of years, which in this last winter has resulted in some growers achieving as much as 90 plus kilos. Those are huge numbers. And then if you take the results from Gates and Howling and you put them in contrast, you're all of a sudden at 85 to 110 kilos. Now mind you, we started with that 35 kilo greenhouse. And I think ultimately that is what this whole seminar has been about, resources. Because with the same amount of resources that we used to use to produce those 35 kilos, perhaps a little bit more, but it's not that much more, we are now producing 85 to 110 kilos. So you can imagine what a saving that is per pound or per kilo of tomato. And what it all comes down to every single time is your basic photosynthetic reaction. Right? I mean, we worked on sun by getting clearer greenhouses, by by getting energy in the plant through supplemental lighting, whether it be LED or HID. We worked on CO2, we worked on the water with grafting, with hydroponics. We worked on optimizing our leaf area index and getting better penetration into the crops by the recent developments in the last, say 5 to 7 years with the diffusion of the roof coverings. And we're controlling the temperature, and we're trying to minimize the dissimilation. When you put that all together, you say, okay, now I know what I need to build. Wrong. Again, it comes down to decide what you wish to grow, where you wish to grow it, how and when. And all of those things combined will lead you to an answer which can then develop into a design. And that design you can do through consultants like myself, with builders like Adam. There are many, many sources out there that can help you with that. But really, there is no cookie-cut greenhouse. In this day and age, every single greenhouse is custom. And that's the beauty of it, but it's also the difficulty of it, because it's really so specific. That's it for me right now. We can do questions after this also. You want to go first?
Sure. That was your intro?
Yeah.
Okay. Agritech Greenhouse Manufacturers is a 41-year-old company based out of San Francisco. We have gone through the whole spiel. Everything started from roses to cut flowers to R&D, and now we're into vegetable productions. It's gangbusters. I've heard referred to as gold rush. You guys are all here for the right reasons. We're all going the right direction, and we personally at my company have a solution for everybody from the 50 cents a square foot to 20 and beyond. I've seen excellent crops grown in low-tech and high-tech greenhouses. So it's a lot. Although it is as much control as you have over your environment, it's also the grower that you have working in that environment. Marco and I were discussing, you could have a hell of a greenhouse and a horrible builder, and you're going to have a horrible greenhouse. So there's a lot to it. Like I said, it's not a cookie cutter thing. To go over kind of two of the trends that have come up recently, and what we're seeing a lot of is insect exclusion and positive pressure cooling systems. Insect exclusion, simply by screening your air inlets and your outlets, can, with proper size and proper engineering, reduce up to, my customers tell me, 90% of pesticide use. So now you're not having to go in and spray the entire greenhouse. You're allowed to come in and spot treat. That's a huge advancement, huge savings for the grower, huge expense that you're not having to put out there. That coupled with entryways, insect exclusion on your entryways, now you're also preventing bugs from getting in as people enter and exit every day. To touch kind of on the positive pressure thing, positive pressure cooling is something that's just kind of now becoming a known thing. What it really allows you to do is maintain a much tighter temperature differential from end to end of your greenhouse in a much larger greenhouse. Traditionally, negative pressure system was 144 feet. It's kind of the ideal. With the positive pressure, you can now increase that to well over 250, 300. And not only is it the added better differential in temperature, you're also now pressing air out of every one of those cracks and holes in your greenhouse, so bugs are not coming in. It's also, I believe, to be a savings when you guys do your installations. In the negative pressure situations, you had fans at one side and pads at the other. Now, with the positive pressure system, all your equipment is at one end of this house, so I believe you're saving on your installations. Also, that coupled with variable frequency drives on your motors, really allows you to have an energy efficient greenhouse, one that can be not only saving you money, but you can better control it. You can play it like a symphony, as someone once told me. So our company has everything for, has something for everybody, from high tunnels to fully controlled environments. And would love for you to come by and see my booth, which I've pretty much broken down, but I do have some cards and some thumb drives and some catalogs.
So we're going to keep it very easy. We figured questions that we can answer will probably be the best approach in this, because, again, this is very specific, focused on your needs. There's no generic here. So if there are any questions, go ahead. Yep, kilogram. Yeah. That is correct. Yeah, it was in those trials or in those production facilities. They were growing, I believe it was Comet from the River seeds, and it was on a year-round basis without the use of supplemental light. It was purely with sunlight that they achieved those productions on a year-round basis. Yep. No supplemental lighting. Yes, go ahead. Yep. That's a good question. To give you a little feel for that, a lot of that depends also what type of structure is it. Are we talking, like Adam is talking about, an over pressure greenhouse? Are we talking an under pressure greenhouse? Are we talking natural ventilation? In a general sense, I would say higher is always better, because you get a more steady climate at plant level. There's less quick reaction when your windows open up, and let's say it's still chilly in the springtime or in wintertime. You'll have more chance to gradually warm up the greenhouse, and the windows will respond slowly according to that warm up. If it comes in too fast, the plant will basically stop growing for a moment. The head will say, I don't like it. The roots will keep pushing. You can get all kinds of problems, fungal diseases, etc. So yeah, we tend to like it on the high side. The flip side of the coin is that, and I'm sure Adam will point it out, your diameter, your thickness of your steel columns is going to be very cost prohibitive. I remember when at Boeschelboy, a company I used to own, when we went from 5 meters, what is that, about 20 foot, up to 6 meters. In steel cost alone, I believe it was an additional $100,000 or something like that for 4 acres. So that's a consequence that you have to realize, because it doesn't come cheap.
And to add to that, the higher you go, you're going to have to heat it, you're going to have to cool it. The higher you go, the more heat it takes to maintain that temperature.
No.
The initial.
That's not completely true. There's a little bit of additional cost, but your heating cost is depending on your heat loss. Your heat loss is depending on the square footage of glass or plastic. The roof surface, it doesn't matter if you're 4 meters or 10 meters high, your roof surface is the same. The only thing what changes is your circumference and your percentage of increased heat loss is limited. The advantages
but there is a limit to it. I mean, of course, you can build as high as you want, but if you're in a very windy area, for instance, you're going to need some really serious wind bracing, because the higher you go, you can imagine how much pressure you get on that sidewall. You know, I mean, they calculate easy nowadays with 650 to 800 Newton meters of pressure, and that's a huge pressure. You need some serious cross bracing to offset that. Any other questions? Yep.
Well, I think Marco's slide was essentially kind of showed how it is, where you've got your pad system here, and then you've got your fan almost butted up against it. And then the air is delivered either under or above the crop through a convection system, similar to the old days of heating. So you're actually forcing air in, and that's why you're able to get such a tight differential in temperature, because when you're pushing that air through, it's got a lot. It's escaping through small holes, and it's got less, solar gain as it goes through, which you're going to put into your crop, and you're going to be able to. Actually, a lot of the guys I have doing positive pressure say that the coldest side of the coldest 3 degrees cooler at the far end of their house and 2 degrees cooler at the start of their house. So, I mean, no matter what it is, so your temperature differential is awesome and well above what you could ever expect to get from negative pressure. Does that answer it? And then you can couple insect screen to the side of that, so now you clean the air that gets in, and then yeah, it probably does change quite a bit. Generally, what you use
It all depends on your length, the length of your row, the width of your row also. So pretty common in the vegetable industry is 1.60 m, but nowadays with these type of greenhouses they tend to create a little bit more space, because 30-inch tube is pretty large, but I've seen them as large as 3 feet, a little over 3 feet. So you can get some serious sizing there, so you need to create some space. My origins are in the Netherlands, and we tend to make fun sometimes of the Belgian people, like they tend to do in the US with the Polish. But we basically have great respect for them when it comes to lettuce growing, because they are the masters at growing lettuce. And if there's one thing that I've learned from them, is for the longest time they wouldn't go to the Venlo greenhouse. They continue to use the wide span greenhouses for their lettuce, because of the extreme high peak where their continuous vent was, gave them again that same time and for the air to blend and mix before it would hit the lettuce. Now keep in mind, lettuce is a very sensitive crop. We can think of it that it's so low to the ground and what can happen, right? Well, lettuce, if it gets too much of a shock, you get glaziness or a leaf tip burn, and the product is useless at that point. You cannot bring it to auction. So, to answer your question, yes, now that we have the tall Venlo greenhouses, the Belgians are actually building Venlo greenhouses for their lettuces. So, yes.
Yeah, my customers generally, when they're doing a vine crop or they're doing a leafy green crop, the leafy green is generally lower. Yes, correct. You don't. This is what my customers are doing. Is a taller gutter for vine crop, because obviously, like you're saying, you got a much taller crop. You've got air. You need to get in there and do your pruning and your maintenance. It's not required, according to most of them, for a leafy green crop. In fact, lower.
It's very hard to generalize. Like I said in the beginning, it's very specific to the application. But to answer your question, the question was, does it apply to both crops? And yes, it does apply to both crops. Whoa. Those are a lot of questions.
In an area where you have such high light intensity like you have here, obviously a curtain system is going to be great for you. You can, utilize it two ways: shade in the summer, and then a heat retention in the winter. That and maybe diffused covering. I don't know necessarily what the blossoms require.
I think honestly, when you want a good answer on this, what we need to do is we need to sit down, look at your cultural data from this area, see what is possible, work together with a good designer, a good company. Could be Adams, could be somebody else's. It doesn't matter, and design the appropriate building for your needs. But that's not something that I can just give you an answer on here in 1 minute. But after this is over, we can get together and I can perhaps answer that.
Maybe just sort of a follow-up to that. There's a lot of information on the web that's really kind of current or out of date or totally bogus. What things were on the
You're asking if there's still published data that we think has been refuted and no longer valid.
Where to begin? What I could recommend is that there's on a growing technical side, there's a good publication that is published online. I believe the website, I'm doing this off the top of my head, is www.ingreenhouses.com. And there's a link there for their digital editions. I believe there's 4 or 5 digital editions that they've posted online for over the last 2 or 3 years. I think there's about 2 per year that come out. What they do there is they take the most important articles that would apply abroad, and they've translated them into English. This is derived from a Dutch trade magazine. That I'm trying to answer your question here first to get you more accurate, up-to-date information. Okay. Then your other question is for what would you not do? In this day and age, I would not build a tomato greenhouse like my grandfather did, where if I walked up straight, I would hit my head against the gutter. Yeah, I mean, sorry. Yeah, and lower. I would really like to build something, what Adam was referring to, with positive pressure. Something with the opportunity to actually control the climate better and better inside the greenhouse. Because the more we are in control, the more we will yield at better quality, because the plant is less stressed. So you get better quality, better shelf life. And also having more pounds ultimately leads to a lower cost price, because this is a fixed cost business. No matter how we look at horticulture, it's a fixed cost business. No matter whether you harvest a lot or a little, your input costs are basically fixed. So it is very important that you get good production. It's very important that you get good quality, and it's very important that you get a good price. So I hope that answers it a little bit, but there's so many things that have changed over the last 30 years that I honestly wouldn't know where to start. Glass percentage, transmission percentages have gone up from anywhere in the low 70s, and nowadays you can get easily, I mean, standard is 91.5% light transmission, and that is at a 90-degree angle. What is more important to look at is the hemispheric value, so what is the average over the entire day as the sun progresses through the sky. You're looking at some really good glass panes right now that can produce anywhere from 83 to 85% hemispheric light transmission. That's awesome. You wouldn't build these days any row crop with, I think, some kind of haze on it. Like if you're looking at tomatoes, or particularly if you're looking at cucumbers and bell peppers, sweet peppers, there are huge gains to be made by getting a diffused glass on your roof, which 5 years ago nobody would build.
To add to that, I was in a 100-year-old greenhouse just a couple months ago, and they're turning out great stuff. So, absolutely, the more control and the better, and the more high tech you have, the better it's going to turn out. It's going to be. But no saying that you still can't do a real good job in an old-school greenhouse.
You mentioned positive pressure. How many times do that?
Instead of a negative pressure system where you're pulling air through pads and then exhausting it out the other side, you've actually pulled air through pads and then you're pushing it through a convection tube. Two-stage?
Inside the greenhouse you have the positive pressure, and in the air inlet chamber you have a negative pressure, because you still have to suck it in, right?
So positive pressure inside the greenhouse, how do you do that?
Typically they work with planen walls, so they have a.
Pad wall.
Can I get that picture back up or not?
Yeah. Yeah, conventional greenhouse equipment for the most part.
But how is that cool air?
Because you're pulling it through a pad. You're pulling.
You blow through the pad.
Correct.
The pad first, and then you blow it in.
Correct.
So two-stage.
There you go.
Yeah, if you can get
Well, you don't necessarily need to run your water through the pad. If like you say, air gets saturated to a certain point and it won't be cooled. Beyond that point, adding water to that won't cool it any further. So, a lot of air movement in high humidity areas is good. Maybe a higher eave if you're building from the get-go. A higher eave would be helpful. Lots of air movement, pushing that air through. It's kind of about like you can use it to an extent, but like once you've oversaturated that air, it's not going to take any more, and it's not going to cool any further.
And what you have to keep in mind also is, if you get that air movement going, even if it is humid, and even if you cannot do all that much with perhaps a pad and fan, compare it to yourself sitting in the summer when it's hot and humid. If you sit behind a glass wall out of the wind, or if you take the glass wall away and there's a little bit of a breeze, it makes you feel better, because even though it is a high humidity, that airflow over your arms and legs and whatever, it still allows you to cool yourself a little bit, and it's the same for the plant. So a little bit of forced ventilation helps in that sense better than the passive ventilation, because what tends to happen when it gets that hot and that humid is that there's not that much wind either. So your windows, they might be open, but you need that chimney effect, so you need some wind. The height of the greenhouse does help there, by the way. The higher you go, the more chimney effect you'll create.
What criteria do you look for when selecting a controller, and what controller manufacturer are you using for your houses or
You want to take them?
I'll start it. It's a long one. Entry level. There's everything from entry level to all the control in the world. Entry level currently we're using like a Link 4. It's very user friendly, digital interface. It's very good. Also to go with that is a microgrow. And those are both two very good entry level controllers that will pretty much give you about anything you want. Track your usage. All your set points, ramp up, ramp down. I've got a couple that are running on a Link 4 actually, and then above that we do use Argus, and there's Hortomax and Priva, the very the nth degree control.
Yeah, and if you look at those manufacturers, then within each manufacturer product line, you have choices. You can go to for instance, if you take Priva as an example, but the same goes for Hortomax. You can go from a maximizer as a startup unit that can do a lot. You can go all the way up to the whatever their newest version is nowadays. Yeah, is it? Okay, yeah. So, but they have literally the power to control anything you want. The question is, do you want it?
Yeah, and how much do you want to spend? I mean, one of the two entry level guys I mentioned, you can get in for as little as $1,500.
Right. Yep.
And
A maximizer will start, depends a little bit on how much you configure it, but at a retail level, I would say you can probably get it around $7,500, $8,000. But that is quite a ways up. I mean, then you get the full Priva software behind there. So it has quite a bit of capability.
In that will obviously do irrigation as well, whereas the Link 4 micro won't control your injection system.
that's a good question. I think
I'm saying the maximizer though, right?
Yes.
yeah.
Yes.
Yeah.
And, but you can get them from Hortomax, and you can get them from Hobodorn. One of the things that was interesting yesterday, talking with Michael Giglio about that Gates project that they built in Monaghan's, when he mentioned to me that it was very complex for them to start it up. Yeah, a lot of technology in their greenhouse. And then the question that you have to ask yourself: how skilled is your manager? How skilled is your grower to manage all these variables?
How useful is the data?
Right, and how much needs to be on the foreground? So sometimes it might be better to spend a little bit more money on the climate control side, because if there are many different things that you need to control, they can help you write a little bit of software so that the user interface is very simple. So the manager can do what they need to do. They can be out there in the greenhouse managing the crops, making sure that everything is right, and not have to worry the whole time, oh, what is happening now? Where do I need to go now? Oh, I need to change the set point. I got to go to 4 different pages. You don't want to have that distraction, particularly not in startup phases.
So you're saying work with, say, Priva to help develop the interface a little bit better for you, or?
With a manufacturer, anybody. I mean, I don't mind who you use, whether it's
You're saying that's what you're saying.
In this case, it was Hortomax, actually. So, but the same type greenhouse, if you take, for instance, the Kubo greenhouse, at Howlings, I believe it's controlled by Priva? No. Who controls it at Howlings? I don't even know. It was Argus, I believe.
Yeah, at one point.
Yeah, it was Argus, and they switched to Priva. Is it still Argus? I thought they switched. Yeah. So, and the main reason for that was, the lack of simplicity. It was too difficult. There were too many distractions, and sometimes it wasn't capable of doing the things that they needed to do. So,
I mean, just like our PCs, they say we use 2 to 10% of the capabilities that they really have. I mean, most of these things will have far beyond what you really care to know about, or most people would care to know about, or actually use.
What kind of temperature differential are you getting, say, in like a desert climate like this, with the negative pressure versus the positive pressure?
As the air hits the pad, when it comes through the pad, or as it you know.
Like inside the greenhouse, like how much temperature differential is that 5 or 15 degrees outside?
Same.
We live in a low humidity environment, so is there a huge difference between positive pressure versus negative pressure with cooling?
No, it's not going to cool the air anymore when it comes to the pad, but it will allow a more uniform temperature throughout
Distribution,
the
yeah.
distribution through the house. Whereas negative pressure, your air is constantly heating up as it passes through your pads and towards your fans. Because we're trapping the air in these tubes, it's not having a chance to heat up until it is actually dispersed. But about 30 degrees.
So even in the desert climate, it's not cool, it's kind of 30 degrees temperature.
Particularly in the desert.
Yeah, the dry air lends itself very well to cooling your pads.
Yeah, I was in Minnesota, and we looked at one point in doing something with that, and I had a lot of conversations with the technical people at Village Farms from all the things that they learned from the Gates project, and came to the conclusion pretty quick that yeah, we could probably do something during the day because the humidity was low enough during the day, but it wasn't very much, and let alone when the sun would set, when you really need the coolness, because a lot of the stem crops like bell peppers, tomatoes, they really like to quickly drop off at night because they're like a tomato for sure is a high desert plant, so it likes that quick cool down. And if you cannot give that, you get problems with proper setting, and that leads to quality problems 7 weeks down the line. So you need to really resort to different cooling techniques if you're in a humid environment.
You see a lot about geothermal cooling and heating, and you maybe expand on the benefits and
Well, the big benefit of geothermal, of course, is there's plenty available once you're set up. The negative is it's extremely expensive. When you go into a greenhouse environment, you need to cool such enormous amounts of energy. To give you an idea, in Minnesota we researched it. We had the Jordan Aquifer underneath our greenhouses, which was a slow flowing aquifer, which lends itself extremely well for storing the heat long term. We did a whole study on this and came to the conclusion that with 3 acres of cooling, we could heat almost 9 acres of greenhouses. That's how much cooling you would have to do in summertime, and that's because we have that high humidity in Minnesota. The lower your humidity is, the less cooling load that you have also going into the evening, because the air just cools down a lot faster. So what are the advantages? The advantages are that it's a very solid system once it's up and running. The disadvantages are extremely expensive, and you have to pass quite a few of legislative hurdles. We have no problem with fracking, but the moment you start storing heat in water, in what's essentially the drinking water supply, you get to deal with quite a few different organizations, and it was not as easy as it was not a very easy endeavor. So we actually, in the end, said no, we're not going to do this.
so it's not a very common strategy in use currently, but
I would say right now there are, Kees, correct me if I'm wrong, about 4 or 5 companies commercially that do it.
groups of, there are at the moment 5 or 6 active wells.
Okay.
Each well supplies several companies.
Yeah.
And there is, and then there will not be in Holland.
Yeah.
And there is a lot more coming.
I think what you're going to see more is basically earth heat, if you will. So not geothermal, but go deeper and get the warm water out. I think that is something that is being pursued a lot more in the Netherlands right now, and I know that in the areas where heat is not very deep, that can be a very interesting option to at least offset your heating costs in winter. But the retrieval from different layers in the aquifer and storing the heat and bringing it into a different layer of the aquifer, and then in winter reversing that flow, that's extremely expensive at this point, and I think you're going to get wound up in a lot of red tape.
Spare one tricky questions for, say, dam water, external, and top up system.
You mean like rainwater?
Dam water, that is installed in
When we were here yesterday, we heard from the food safety people that the first thing that I would do personally, I would find a location where you have city water, because honestly, for food safety, that takes half the requirements of the plate right there. But I would recommend, if you want to talk about water treatments and those kind of things, there's a gentleman sitting right behind you from DRAM, and they have some good options, some good alternatives. They use a whole host of things these days. DRAM likes to use like an ozone type application. I know of organizations that sterilize all their incoming water with low density UV. You have high density UV installations. You can go into a heater where they keep the water at 90 plus Celsius, 200 Fahrenheit, whatever, for X amount of seconds, and then cool it down again. There are several options and several methods, and each of them can work, and some work better than others for your application. It really all depends on what exactly you're looking for. So, but I hope that answers it. I don't know.
So there's been some discussion here frequently about negative versus positive pressure.
Yep.
Could you tell some of these people, in your estimate, what benefit is one versus the other than pushing their outdoor factor more uniform air flow to the using food? What is the operating pressure of a negative versus the operating pressure of a overpressure, positive pressure, if you will, and are the negative benefits associated with overpressure?
If you don't have a
That's our question, I know.
if you don't have an air release, you could essentially overpressurize your house and start
Blow your roof off.
blowing panels out.
Look, are you operating at, I'll use set pressure, inches of water. Do you have 22, 25, 23, do you have guidelines, do you know? What's the rule of thumb? Negative rule of thumb.
0.5,
That's 1 Pascal, isn't it?
0.05 or 0.1?
0.05.
It's very little. It's because with the least amount.
Pressure, do you know what that applies to? Because now you're creating constant pressure in the house at all times, whether you're cooling, heating, or anything.
What they typically do is they put in the gables, they put in an air release louver that has a weight on it. Okay, and the weight corresponds to a certain pressure in the house. You exceed that pressure, it opens up the louver. If you wouldn't, again, you would blow out your gables, but also doors and all that kind of stuff. You wouldn't be able to open doors and close doors. It'd be extremely difficult. So I don't know if that's what you're...
You don't know. I guess I'm looking at it as an equipment manufacturer point of view. Is when we negative pressure a house, traditional old style.
Yeah.
Fan kicks on, you're steaming the air, 100 intervals,
Yep.
60 intervals,
Yep.
500 intervals, fan shuts off.
Right.
An overpressure system, do you not have constant energy draw, constant utilization of fan, pressurized that?
You do.
Will the grower not have to anticipate a little bit more? It's a good system, it's a beneficial system, but large scale down doing it. Is it not maybe a little more energy inefficient for some of those smaller medium motors that have that constant use of energy?
It totally
If I take
depends.
you long, I'm just trying to answer this.
It depends on really what you want to achieve. I've got citrus growers in California where one Asian citrusillid comes in their house and they can be shut down for 3 years. For those guys, maintaining a positive pressure 24 hours a day is
Essential.
what they want to do. And you'd actually really be surprised at, one fan can really, maintain pressure in a mostly closed greenhouse fairly easily. And it's all in correlation in relation to your air outlet, right? Maintaining the pressure inside of that house.
It all comes back to the beginning statement, right? There's no cookie-cut solution. You have to really look at it from greenhouse to greenhouse, and in some greenhouses it's better to go with a positive pressure. Some greenhouses it might be better to go with a negative pressure. Some greenhouses it might be better to go with a traditional ventilation, traditional roof. Some greenhouses might be better for poly. Some greenhouses might be better for double plastic. Who knows? It all depends on what your specific needs are. Yes? Latent versus? My English is good, but sensible. Help me out.
Is that like unit heaters versus boiler systems? Yeah.
I understand the latent part. What is the sensible one? Sometimes I still have to learn some English words, so I apologize for that. But so are you talking about like he's saying? Are you talking hot air heaters versus water heating systems, or? Sorry about that.
I think it would be latent would be is really referring more to something like a heat pump. You're extracting the heat out of the atmosphere, and sensible is a heater or
Yeah. Well, this is the big discussion, and that has been going on for many, many years. For instance, in Leamington, in Canada, where a lot of people were used to working with steam heat. And aside from the efficiency problems that they had with steam boilers, with the high gas prices, that they couldn't continue doing it, but they are all switching, for instance, to hot water heaters. And hot water heaters do have a latency issue as well, because the advantage of a steam heat pipe is the moment the sun comes out, you turn it off, the pipe is cold almost instantaneous. You do not have that with, for instance, a hot water pipe, and sometimes that gives a problem.
Okay, phase change materials. Do you incorporate those into your design?
Like you mean glass changing?
So there's materials now that are being talked about that you can put into the foundation something that may change the surface from liquid to solid.
Mhm.
So phase change
Yeah.
material, that's
The salts,
stored heat energy,
right?
so it comes back out later.
Right.
Does that ever be incorporated into the design?
Only in theory so far, what I've heard. In trials,
Yeah.
I have heard that there are some trials being done with certain salts for cooling, particularly in areas where you have high humidities. Then these salts can come out and help in a positive manner. But I have not heard of any other things in modern greenhouses now.
Not commercially.
Not commercially, no. They're researching it, yes, but it's not commercially available.
I've seen the technology. I don't know. I haven't seen it in motion, or it's only been test areas that I've seen. But I mean, it's PV. What I've seen is PV laminated in glass. It was feeding into the reverse innovator, and it was very small scale.
And the crops that I've seen them do it in are the crops that don't necessarily need the most amount of light. They tend to use it in crops that use shading quite a bit. And at that point, it doesn't matter if you use some of your greenhouse area to put some solar panels into it. I have not heard of them using it. And usually the economics don't work out either. Because if you have solar power, you get, I don't know, 12, 15 cents, depending on where you are in the country, for that if you deliver it back into the grid. Yeah, and at the same time, you can buy from the grid power at about 6 cents. So it wouldn't make any sense to use that power yourself. You would sell that back to the grid and then buy from the grid the power that you need for your lights. That'd be a lot more cost efficient.
I think at this point, if you've got room for a legitimate solar panel that's dedicated to maintaining that, the integration is great, but it's still in the infancy maybe.
There are a couple of good-sized companies in France and Italy that have commercial setups.
Yeah.
But it's different.
Yeah.
Way from a commercial buyer. Probably heavily subsidized.
Yeah. Yeah, and for those of you, when you're in areas where electricity is extremely high, yesterday, I don't know who was giving that presentation, they showed a little turbine generator with, might have been today actually, with the option of capturing the heat from it and the electricity locally. Consider island options. Sometimes these island options, your utility might actually be very interested in that. Particularly if you're a smaller grower, they like to do those 50 kW, 100 kW units and put them at your facility. And at that point, what you can do is you run your natural gas through there, which on average runs about $5-6 in throughout the United States. And you can roughly, as a ballpark, say whatever you pay for the gas price, put it in pennies and you get your electricity price, and then your heat is for free. Okay, so if gas is $6, you have a 6 cent a kilowatt hour price electrically, and then your heat is for free. And if you have a real good generator, they also capture the CO2, bring that through the greenhouse. Now you get that for free as well. You know what? Sometimes you can talk with, like in Iowa, if you want to do something there with Lion Energy, they might furnish the whole thing. At that point, you will have to pay something for your electricity and your natural gas, but you still get an offset because it's produced at your site. But I think you can accomplish most of those goals if you're upfront and you do your research and you go out to your utilities, because a lot of these utilities have certain mandates to save energy, and we're all paying for this. When you look at your utility bill, there's an energy conservation fund that a percentage of your bill goes into that, and for every home owner, but also as an entrepreneur, you can apply for that money. We did a lighting project last year, 2 years ago at Boy. We did very efficient lights together with curtains, $1 million project. We applied for grants and all that kind of stuff, and we got $100,000 from our local utilities to help us with that investment. So don't be shy. Ask. There's a lot of money available from your local utilities if you go for energy-saving investments. And as simple as an energy curtain in your greenhouse. Go to your utility. They will pay quite a bit of money.
Conversion from single to double poly,
Right.
corrugated to twin wall,
Yep.
replacing old energy curtain material that's
Light bulbs.
not there, light bulbs.
Absolutely.
Yeah.
Yep.
And they don't advertise it. You have to ask.
They won't. No, typically they are grants. You don't have to pay it back.
Or rebates.
Yeah, rebates, or however you want to look at it. It does take some homework, don't get me wrong. They're not just going to hand you the money. Okay, but it is available. Any other questions? Boy, there's several companies out there that manufacture the fan. You're sitting next to one.
Yeah.
There are several manufacturers. Correct. Well, actually, they've gone. Perhaps you want to elaborate on that. You got the AC. Yeah. Yep. When we would build a greenhouse at Bushboy, I would contact Multifan and say, okay, I want to have so many fans, this voltage, hertz. They wind it the proper way. We put it on the VFD ourselves, go to local utility because we're buying a VFD, get money back. Okay, I keep saying this because it's a lot of money when you add it all up. Yeah, right. And then you basically hang the fans yourself, and the controller goes through a simple 24-volt dry contact with whichever controller you choose, whether it's Priva or whether it's Hogendoorn or whether it's Ordemax. Doesn't matter, whichever controller. If you use a variable frequency drive, what you do at that point is that they typically say about 15% as a minimum. Okay, so then let's say that's about 10 hertz. Yeah, so from 10 hertz to 60 hertz, you get a 0 to 5 volt signal, and your controller will know if it's at 4.3 volts. That it needs to give a signal for 4.3 volts if it needs so many hertz. And that's your setting. Whatever you program in the computer that you want, the controller will do it. It's your choice. That's also the difficulty. You have so much control, and a lot of times we end up with human error inside the greenhouse. And that is, for the climate computer manufacturers, that's the big challenge. I was at Hordimax just a couple of weeks ago at their headquarters in the Netherlands, and I posted that very question to them. I said, you have to make this simpler. The controls for the grower need to be simpler, because they're not researchers. Okay, we don't have the time for that. We have to deal with people. We have to deal with selling our product. We have to deal with biological control. We have to deal with ordering fertilizer. We have to do so many things. We don't have the time to sit down and fully, with a fine-tooth comb, go through this climate computer. That's just not possible. There's so many settings on dealer level and on user level that's impossible. But they're working on that, and they said during the upcoming trade show, the Green Tech in Amsterdam, that they're going to be showing some new technology that gives it the possibility to hide a lot of that stuff to the background. Oh boy. let's say an average greenhouse of 4 acres, we had 2 I/O boards, input-output boards, and I would have probably about 50 hookups in there. Yeah, we would have measure boxes, 4 of them in a 4 acres, so one per acre roughly. We would have infrared. We would have water sensors, weigh scales. We would have, of course, your vent control motor, your motor controls, your curtain controls. I mean, you name it, the fans. There are many free heating. I haven't even touched on heating. So there are many different sensors.
Budget. Think about your budget.
Yeah.
What, are you limitless?
After this, because I
Yeah, I
think
was
we're
gonna
at that
say,
time, I'll
I think
I'll
you
come
should
over.
hire Marco, actually. I think that's the answer to this one. But I'm sure he'd be more than happy to
Yep, no problem.
chat further.
No problem.
Thank you so much. Thank you to both of you.
Okay.